Okay, so we are continuing chapter 1. We're going to do the first part of section 4, which talks about the metric system. So we're going to learn about the metric system. We're going to figure out how to do conversions, and we're going to figure out how we express numbers in scientific notation. Okay, so the metric system. We use this when we're doing science so that we can easily compare our results to those of people all around the world. So you can see that all the countries in green, which is pretty much every country but us, uses the metric system in their everyday lives. We're one of the only countries that really hasn't adopted that. But whenever we do science, we do use the metric system, again, so that it's easier to compare our results with everyone else. The metric system is also easier to use because it's based on powers of 10. And it has multiple names. Metric system, International System of Units, SI, which is short for this here. I believe that's French, the French name for it. So this kind of just shows you how we have our metric system based on powers of 10, which is a little different than the imperial system, which we're used to, where we have, for example, 12 inches in a foot. Okay, so here are some kind of standard units for the metric system. These are kind of the go-to measurements for each of the things we're measuring. So, for example, length will typically be in meters, mass will be in kilograms, time will be in seconds, and temperature will be in Kelvin. This kind of allows us to know that when we have derived units, which will be on the next slide, that they're kind of in a standard form. We also have prefixes. So it really all starts with our base unit, which can be meters, grams, liters, things like that. And then we have prefixes, which kind of tell you how large that number is. So kilo, mega, giga, and then on the smaller end, centi, milli, micro, nano, and pico. So here are just our standard units of measurement for the metric system. Okay, so here's kind of the derived units I was talking about. So for example, density, which is mass per volume, will have kilograms per meters cubed. So if we were to express this in grams per meters cubed, it would be a different value. So anytime we're doing measurements where we have derived units, it's very useful to have kind of a standard unit of measure. And in this case, we use kilograms, which this one's the only confusing one because it does have a prefix. It's not just grams, even though the true base is really grams. Okay, so we got to do some conversions. So we want to get 5.0 M, and we want to figure out what that is in km. First things first, what is M? M stands for meter. So meter is a base unit. Again, our base units are things like meters, grams, liters. Anything with a single letter is going to be a base unit. And base units have a power of 10 to the 0. That is equal to 1. If you type 10 to the 0 into a calculator, the answer will be 1. Kilometers, which is what km stands for, and you can look up here, kilo is 10 to the 3rd power. So to figure out how to make this conversion, we need to subtract the powers. So we take 3 minus 0, we get 3, and we know we need to move the decimal 3 places. Another way to figure that out is to say, hey look, we're going from meters to kilometers. Look down here at our handy little chart. Meters is a base unit, and we're going to kilometers, so we're going 1, 2, 3 places. So we have our 5.0 down here. We want to move the decimal 3 places. Since we're going this direction, we're going to move the decimal that direction to the left. fill in our empty spaces with zeros, and our answer is 0.005 kilometers. Notice our decimal moved from here to here. Okay, so another example. We have 1.6 mg with a capital M. We want to know what that is in ng. Capital M stands for mega, so megagrams. And just note that capital M is different than lowercase m, which stands for milli. And megagrams is 10 to the 6th power. Then we have ng, which stands for nanograms, which is 10 to the negative 9th power. So we want to find the difference. 6 minus negative 9 equals 15. And remember, when you have minus a negative, that's the same as plus a positive. So you'll say 6 plus 9 equals 15. So we know we want to move it 15 places. The other way to figure that out is to say, hey, we're going from mg to ng. Here's our capital M, and we move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places to nano. And since we're moving in this direction, we want to move the decimal to the right as well. So here's our decimal here with our 1.6. We're going to move the decimal to here now. Add in our extra zeros. And this is the number we come up with. Now this number looks a little bit confusing, and you might think that you don't know how to say it. I don't know how to say it either, actually. So one way that we can make it kind of easier to understand is by putting it in scientific notation. So that looks like this. 1.6 times 10 to the 15 ng. And just ignore this. Okay. So when we're doing scientific notation, this is kind of the general format. So we're going to have something, point something, times 10 to a power, and then don't forget your units. So here's our example from before, our long number. In scientific notation, it'd be 1.6 times 10 to the 15, because our decimal, which started here, is now going to go after the 1. We always want to have one number in front of the decimal when we're using scientific notation. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places. So we get 1.6 times 10 to the 15. If it's a large number, the number is going to be positive, and if it's a small number, this number will be negative. Okay, so another example, 58 million, and that in scientific notation. How do we figure that out? We say, okay, the decimal's here normally. We want it to be after the 5. Again, we want to have one number in front of the decimal. So we're going to move it 1, 2, 3, 4, 5, 6, 7 places. So again, it's a big number. It's going to be 5.8 times 10 to the 7. Our next example is this number here. Now notice this number is small. It's a decimal. It's less than 1. So our decimal place is here currently. We want it to be after the 7, since that's our first number. So we'll go 1, 2, 3, 4, 5, 6, 7. That's 7 places. So this time it's going to be 7.89 times 10 to the negative 7. So note that it's negative because we started with a very small number. And ignore this. Okay, so that's all for this section. And practice those conversions.